Hello everyone. So welcome to the sixth module of the course Fluid Mechanics and Machinery. As you know, the sixth module covers various types of pumps which comes under our fluid machinery. So basically we have two types to study. One is rotodynamic pump, another one is centrifugal pump. So in this video session, we will cover all the first type, that is our centrifugal pump, or which comes under rotodynamic pumps, its construction and all other details. So first we will have introduction, classification of pumps, and then we will concentrate on the types of centrifugal pumps, its types, work done efficiency, and the minimum speed. So as an introduction, we know that pump is a mechanical device. It converts mechanical energy into hydraulic energy. Recall that we in earlier in last module we have seen turbines. In turbine, we converted hydraulic energy into mechanical energy, which was in turn converted into electrical energy. So pump is just doing the reverse operation, that is, it is converting mechanical energy into hydraulic energy. Commonly, you can say that we are using pump from lower level to higher level. That is, we pump from underground tanks to our tank at the higher tank and the terrace of our building. So for that we use a pump. And now mechanical energy is taken from an engine, or commonly in household we use an electric motor to pump for the smooth operation of this pump. So in short, we can say that the action of a pump is just the reverse of an inward radial flow reaction turbine. So pumps can be basically classified into two types. That is, first one is positive displacement pump. The best example of positive displacement pump is our reciprocating pump, which has a to and fro motion. And the second one is rotodynamic pump, which is our centrifugal pump. So in this session, we will be looking at rotodynamic pumps, or rather centrifugal pumps, in detail. Now, before moving to the details on centrifugal pump, first we will see what is a positive displacement pump. In a positive displacement pump or a reciprocating pump, liquid is sucked and is pushed or displaced due to thrust exerted on it by a moving member. This moving member can be a piston. More than one chamber which is alternately filled with liquid and it is emptied. Example is reciprocating pump. Now, rotodynamic pump, it has a rotating element which is known as the impeller. So as the liquid passes through this impeller, the angular momentum changes and pressure energy increases. And this is the way it is working. Example is centrifugal pump. An interesting topic, or one might be more interested to know what are the differences or how can we compare centrifugal pump and reciprocating pump. Both are different in every manner. You can see the differences. Some of the differences are centrifugal is more smooth and uniform flow, reciprocating is pulsating flow, and there are a lot of comparison which can be done between the two. You can have a look at it. It is self-explanatory. So the centrifugal pump has obviously got some advantages over reciprocating pump. First one, the discharging capacity is more. And if you are using some viscous fluid such as oil or mud, sewage, water, etc., centrifugal pump is more recommended than a reciprocating pump. Can be operated at high speed and there is no problem of cavitation. And also the maintenance cost and periodical checkups required is less for centrifugal pump. So because of all these reasons, it is more advantageous to use a centrifugal pump than a reciprocating pump. Now we come to the our today's topic. That is, today we will be looking at centrifugal pump in detail. So as I have already told, it is a rotodynamic pump in which a dynamic pressure develops for lifting the liquid from a lower level to higher level, and subsequently the pressure energy is increased, and this is the principle of centrifugal pump. So this is a figure showing the construction of a centrifugal pump along with its working. So you can divide the from the impeller point of view, you can divide it into two parts. That is, below the impeller you have the suction side, and above the impeller you have the discharge side or the delivery side. So accordingly you can denote it as HS, which you can see in that figure. HS means suction head and HD means delivery head or the discharge head. Now the below the suction side, first you have a strainer to filter the things, and then a foot valve, and water is taken up through the suction pipe and it reaches the scroll casing, and from there there a pressure gauge or a vacuum gauge is fitted there to measure the pressure, and then water is forced into the impeller and it rotates, and there we due to the centrifugal action the pressure inside the pressure of the water inside gets increased, and this pressurized water is then again taken to the delivery side. So there in the delivery side you have the delivery flange or the scroll case delivery flange, and in at the delivery flange there is also a pressure gauge to note the pressure, and then we have delivery valve. Once the delivery valve open, then the water is taken to the overhead tank. So the working of centrifugal pump is very simple. um, Now we'll look at one of the each part one by one. So as we have seen in the last slide, there are four main parts. One is impeller, casing, then we have suction pipe and delivery pipe. Now impeller, as you know, is the rotating part of the centrifugal pump. It is used to raise liquid from lower to higher level by creating the required pressure, and it also gives the whirling action for the liquid. Now impellers can be classified into three types: closed or shrouded impeller, semi-open impeller and open impeller. We shall look at each one of these now. So this is a figure showing the various three types of impellers: open, semi-open and closed impeller. So first one, closed or shrouded impeller. As the name indicates, it is closed and vanes are provided with metal cover plates on both sides. The shrouded plate, it can be crown plate. It is provided on the lower or the base of the plate. Now the advantage of using this closed impeller is you can have better guidance of the liquid. You can make sure that the liquid doesn't spill out, and you can guide the liquid through the impeller. And it is suitable for pumping pure water which are free from debris or any impurities. Otherwise the parts will be getting damaged. So this is the figure and the image of a closed or shrouded impeller. Now the next one is semi-open impeller, and we have the vanes only on the base plate and not on the crown plate. So only one side is open and one side is open and one side is closed. So this is suitable when water contains some waste or debris. So this is the image showing semi-impeller, semi-open impeller. Now open impeller means there is no crown plate and no base plate. Used for pumping contaminated water or which has suspended matters like paper pulp, sewage, etc. And it is less liable to clogging because it doesn't have any restrictions or coverings. Now the second part is casing. Casing, you have already seen casing. What is casing in the construction of various turbines? It is the same function here. It is an airtight chamber surrounding the pump impeller, basically to protect the impeller and to avoid the water to spill out. So casing will contain pump impeller, support for impeller bearings, and suction and discharge arrangement. And as you can know, the purpose is to guide the water to and from the impeller and to partially convert kinetic energy to pressure energy. Now, casing also we have different types of casing. One is volute casing, Second one is vortex casing, and the third one is casing with guide vanes. So we will now look at each one of these in detail. So volute casing, a figure is shown here. Area of flow gradually increases from the impeller out to the delivery pipe. So which means the velocity of the flow is reduced. When the velocity of the flow is reduced, the discharge pressure is highly increased. Now second type is vortex casing. So vortex casing, we have a separate chamber, circular chamber is provided between the impeller and the volute chamber. You can see that inside that dotted line. So the use of this vortex chamber means the pressure is, if you want the pressure to be increased more, you go for a vortex casing. Now the third type is casing with guide vanes. Impeller is surrounded by a series of guide vanes mounted on a ring called diffuser. Diffuser again, here the function of the diffuser is again to increase the pressure energy. This is done by reducing the velocity of flow. So the working of a centrifugal pump. Step 1 is priming. Priming is to remove the air pockets. Pressure generated in the impeller is directly proportional to the density of the fluid. So to do the priming, uh, first we close the delivery valve, then the impeller starts rotating. Formation of a forced vortex imparting centrifugal head and increase in pressure. Delivery valve is open. As the liquid flows through the impeller, it receives energy from the vanes, and liquid flows in outward radial direction with high velocity and pressure. Creation of vacuum at the eye of the impeller, rushing more water through the suction pipe. And absolute velocity of the liquid leaving the impeller will be very high. High velocity of the leaving liquid is gradually reduced to lower velocity. That is, more kinetic energy will be converted to pressure energy. And this is achieved by shaping the casing, gradually increasing the area, and uniform velocity is maintained. So according to the type of casings used, you can classify centrifugal pump as volute pump and diffuser pump or turbine pump. Modification of the volute pump with a vortex chamber, and a diffuser. The impeller is surrounded by a series of guide vanes. You have already seen what is a diffuser. Mainly the intention is to create more pressure energy. So this is the two types of centrifugal pump, one without diffuser and the other one with rings or diffuser. Now according to the number of impellers used, you can say that you can have single shaft or single stage centrifugal pump which has only one impeller mounted on a shaft, and multi-stage where there are two or more impellers connected on a series. It is to produce high head and to discharge a large quantity of water. So this is a figure showing a single shaft or single stage centrifugal pump, and second one is a multi-stage centrifugal pump. Now according to the direction of flow, you can again classify it as radial flow pump, mixed flow pump, and axial flow pump. Strictly speaking, axial flow pump cannot be called as a centrifugal pump. And again, another classification is depending on the number of entrances. We have a single suction pump and double suction pump. A double suction pump is shown in figure. Uh, which will have large inlet area, and axial thrust will be neutralized. And again, another classification is depending on the position of the shaft, pumps with horizontal shaft, pumps with vertical shaft, etc. Vertical shaft are special types which are used for deep wells and mines. The advantage is that you can use it when there is less space. And again, low head, medium head, and high head. Low head means up to 15 meters. Between 15 to 40 meters, we have medium head, and high head is above 40 meters. Now, this is the work done by a centrifugal pump. We will look at the work done in detail when we do the problems. While solving the problems, we will look at the how to draw the velocity triangles for a centrifugal pump. So you have, as you have seen in that figure, you have two heads, that is head of a pump. One is the static head or the suction head, and HD is the delivery head. So the net head will be the sum of both of these, that is HS will be a HS plus HD. And another, we have the manometric head. It is the total head that must be produced by the pump to satisfy the external requirements, and the expression for HM is VW1 U1 by G minus losses of head in the pump. Now we come to the losses in pumps. There are three losses, that is hydraulic losses, mechanical loss, and leakage losses. So first one is hydraulic losses. These are eddy losses at the entrance and exit of the impeller. And second one, it can be friction losses. And other hydraulic losses are friction and other minor loss in suction pipe, similarly in delivery pipe also. And mechanical losses due to the friction that is happening between the impeller and the liquid, and also friction taking place between the main bearings and the glands, etc. These all comes under mechanical losses. And leakage losses, as you can know, that some amount of liquid will be leaking out from the casing, or this can never pass through. This will, some of the liquid will never pass through the delivery pipe. So these, all these losses, we call it as leakage losses. Now we will look at how where these losses are happening. So in this figure, you can see that there is, first one is shaft, second impeller, casing exit, and delivery exit. So mechanical losses is placed between shaft and impeller, which means that mechanical losses happen while the liquid or the water is passing through shaft and impeller. Similarly, hydraulic losses is a loss occurring between impeller and casing exit. And other hydraulic losses are the losses happening between casing exit and delivery exit. That is why these three losses are placed in the intermediate between each of these components. Now that we have discussed about the losses, we will now move on to the efficiency of the pumps. There are four different efficiencies: manometric efficiency, volumetric efficiency, mechanical efficiency, and overall efficiency. So manometric efficiency, it is a ratio of manometric head to the manometric head developed by the pump to the head imparted by the impeller to the liquid. So it is denoted by eta mano, power actually delivered by the pump by power imparted by the impeller. We will be discussing in detail all these efficiencies and losses when we do the when we solve the problems. Similarly, you have volumetric efficiencies, that is ratio of quantity of liquid discharge per second from the pump to the quantity which is passing through the impeller. The mechanical efficiency is related to power, which is actually delivered by the impeller to the power supplied by the shaft of the prime mover or the motor. So the last one is overall efficiency. As you know, it is output by input. Output is what we obtain from the pump, and the input is what we supply from the prime mover driving the pump. Now, what is minimum starting speed? So it is the when the pump is started, there will be no flow until the pressure difference in the impeller is large enough to overcome the manometric head. So the minimum starting speed that will be required when there is no flow and for the pressure difference to take place is known as minimum starting speed. Now we come to the priming of centrifugal pump. It is an operation in which the suction pipe, casing of the pump, and portion of the delivery valve, these three parts are completely filled from outside source with the liquid to be raised. It can be either water or an oil, whatever the liquid is to be supplied by the pump before starting the pump. Now come to the selection of pumps. What are the things to be considered before we select a pump? So first one is quantity of liquid to be handled. Second one is head against which the liquid is to be pumped. nature of the liquid to be pumped, nature of the power supply, and the pump. If the pump is used only intermittently, corrosion troubles are more likely than with continuous working. So these are self-explanatory. What all things we need to consider before selecting a pump. Now cavitation we have already seen in the first module. It is the same cavitation happening here in the case of centrifugal pump, which will lead to the pitting action. So effects of cavitation, metallic surface will be damaged, cavities will be formed, there will be a lot of noises and vibrations, and obviously the efficiency of the turbine or the pump will decrease. So cavitation can occur in centrifugal pumps also, and it will occur at the impeller or the suction side of the pump, and there will be a sudden drop in efficiency of the head. So for to consider that, we have a cavitation factor called Thomas cavitation factor for centrifugal pump.